Right. So, a very good morning to one and all. Welcome to 2 week student development program on engineering the future, moving from electronics design to industrial implementation, organized by Department of Electronics and Communication Engineering, Dayananda Sagar College of Engineering, Bengaluru. Today we have with us Professor Sneha A.S., who received her BE in Electrical and Electronics Engineering from Don Bosco Institute of Technology, Bengaluru, and MTech degree in Power Electronics from Department of Electrical and Electronics Engineering from SIT Tumkuru. Subsequently, pursuing her PhD from Department of Don Bosco Institute of Technology in the year 2024 in the field of electric vehicles. Currently, she is working as an assistant professor in the Department of EEE DBIT Bengaluru. Her areas of interest and subject specialization are electric vehicles, power electronics, and power systems. She has published many research papers in national and international conferences and journals. She is a lifetime member of ISTE, IEI, and IAENG. I welcome Professor Sneha A.S. Ma'am, you can proceed with your presentation.
Okay, sir. Good morning to one and all present here. Myself, Sneha, Assistant Professor from Department of EEE from Don Bosco Institute of Technology. I thank the Department of Electronics and Communication Engineering from Dayananda Sagar College for giving me this opportunity. So let's start with the session. So the title of the session is Problem Solving and Ideation Session, EV Charger Management System.
No, it
So some of the contents in which we will be discussing today is introduction.
Madam, that full screen mode you please put up. Otherwise, that slide movement will not happen.
Yeah, it's in full screen mode.
Yeah, okay. Yeah, pretty clear.
So today we will be discussing about electric vehicles. So basic introduction to electric vehicles, types of electric vehicles, and some of the components that we will be using in electric vehicle charging system. So why do we want to go for EV charging? And also whenever we are connecting the electric vehicles, so it has to be connected to grid. So how can we connect this electric vehicle to the grid? That is called as V2G. And how can we control that? So if this has to be implemented in the field of research, so what would be the various methodologies or methods that we can go after? That is actually called as research methodology or methods. And stages of implementation of vehicle to the grid, and how these electric vehicles interact with the grid. So how they communicate with the grid, and what would be the advantage when these electric vehicles are connected to the grid. And there are some like application-oriented thing which is being called as grid power peak sharing and also peak value. So and some comparison points related to this we will be discussing. Since we are basically dealing with respect to the electric vehicles, okay, so first thing that we have to do is there are basically three stages of energy transmission.
Slide you have to click on your bar, then only it will come.
It's clicked, sir. Can you see?
No, ma'am. That full screen, if you do it, we can see it actually.
It's in full screen mode.
No, ma'am, it's not in full screen mode. It's in that, now it is coming. You need to...
Now it's in full screen mode.
Yeah, no, it's not in full screen mode actually. That sidebar is still visible, that's why.
Okay. Because when I see from this side, it's actually visible in full screen.
Okay.
So.
Yeah, now it is full screen.
Is it fine?
Yeah. Yeah, please proceed.
Okay. So basically, once we start with the electrical science, there are three main stages that we deal with. One is the energy generation, the other one is the energy transmission, and the last one is the energy distribution. So right from the stage from generation, transmission, and distribution, there are various kinds of variations that has been happening with respect to voltages as well as current. Okay, so when we are talking about electric vehicles, okay, So basically, these electric vehicles comes as a consumer at the distribution end. Okay. So therefore, whatever the byproducts or whatever the energy that is getting transmitted is directly from the generating station. So obviously, we know that in case of generating station, we will be generating electricity. Okay. There are two means of generating electricity depending upon the sources. We have two resources. One is the renewable energy resource, the other one is non-renewable energy resources, which are ideally called as conventional energy resources and non-conventional energy resources. In conventional energy resources, okay, basically which are being called as non-renewable energy resource, so we will be using some of the fossil fuels, charcoals, or whatever it is, okay, which are being used as resource or byproducts which will be used for generating electricity. So here basically what is the drawback is whatever the fossils or whatever the non-renewable sources that we will be utilizing, okay, so they take millions and billions of years to come back to their status, to recycle them. So whereas when we come to renewable energy resources, we have various types of resources which are abundant in nature. Okay, we can regain energy, they are sustainable, to take some of the examples are like solar, wind, etc. Okay, so either by renewable energy resource or by non-renewable energy resource, we can generate electricity. Okay, so that is one part of generation. Next comes transmission. Initially, whatever the energy that is being generated, okay, so that energy will be primarily stepped up in the stage of transmission. That stage of transmission is called as primary transmission. So in primary transmission,
ABC
basically
10
the generated
that
voltage
any
is
scripts are
stepped
in third
up.
valuation?
Okay, so say for example, we have 11 kilovolt of voltage that is being
Yeah,
generated at the
definitely.
generating station. It will be stepped up for about 220 kilovolts or for 150 kilovolts in the next stage. Later, after primary transmission, then comes the secondary transmission. So there are all stages, that is the secondary transmission, primary distribution, and secondary distribution. In all of these stages, we will be using step-down transformers. In these step-down transformers, step by step, we will be stepping down the voltages, and then we will be liberating these voltages towards the distribution sector. Okay, so you're actually in distribution stage. Okay, so there are two variants. One is one form of energy, okay, one form of electricity that has to be got distributed can move up to a single phase. So the other form of energy or the other form of voltage, which is with having a bulb and which has to be transmitted over a long distance and a high voltage has to be transmitted at that point of time, it will be connected for three-phase system. I hope you people will know about what is the difference between single phase and three phase. So here, the vehicles that we will be basically designing, okay, so are adaptable for both. So if it has to be used for a short duration of time, if it has to be used for a limited speed, okay, the capacity or the charging capacity of the vehicle depends upon the source of income for it. Okay, so the amount of duration that is being replicated, so is directly proportional to the speed and the motion of the vehicle. So which is directly connected under the distribution station. So here basically the electric vehicles are powered by electric motors. Okay, using the electricity that we have got from the transmission stage. So here either instead of these fossil fuels or gasolines or diesel, you can go with renewable energy resources which are being generated by solar, wind, thermal, ocean thermal, or sea wave, anything. Okay, so they actually have various kinds of connectivity with respect to grid. So when we are talking about grid, okay, so it is nothing but a place where the energy or the power is being stored. Just like how we call it as a powerhouse. Okay, so in case of grid,
No,
okay, so there are various types of grid. We have microgrid, we have
every time I
microgrid,
have to.
and then we have smart grids. Okay, so where smart meters are being connected, just like how we will be having various digital meters, so which analyzes the performance of the consumer and which analyzes the performance of the distribution end. Like that, you are also in smart grids. Basically, we have all smart meter equipment where the charging and discharging of the vehicle is being internally controlled by the controlling units. Okay, so here the electrical power grid is nothing but so the connectivity of various kind of suppliers or the clients. There will be a number of generating stations. So put together all the generating stations should be connected in a single bar. That is again nothing but it has to be cascaded together so that we get the power in bulb. So that house where we will be collecting the energy, that is actually called as electrical power grid. Okay. So here from the grid, we will be supplying power towards the electric vehicle. So as we already know, this electric vehicles is one of the main dynamic propulsion unit. Okay. So one thing is it has to balance the supply system, and also it has to balance the speed because it will be continuously in dynamic state. Okay, so whenever it is in the dynamic state of operation, so the supply that it has been getting, so it has to be recycled back. Okay, so that recycling back is called as regeneration, regenerative braking. So once the vehicle is in motion, so as and when it is utilizing the power from the grid, okay, so it should recycle the energy back to its battery and it should run on its own. So that is the main strategy that we will be doing in the present generation. So here in case of smart grid, as I said, so all the meters or the equipment that we will be using, so are actually called as the modulators. Okay, so and these modulators which we will be using is continuously changing.
Madam, that
They
slide
change
is
from
introduction only. It's not moving.
no, I'm just giving the introduction.
Oh,
On
fine,
this.
fine,
It's
fine.
still in introduction.
Yes.
Okay. It's still in. So especially in case of a smart grid.